So, have you ever actually stopped to think about how a simple swipe on your phone can instantly trigger a global fraud alert? Or, how your favorite streaming service seems to know exactly what you want to watch the literal millisecond you log in? I mean, it feels like magic, right? But underneath that glass screen lies a massive, completely invisible plumbing system. Today, we're going to explore this hidden world of data engineering, the absolute critical infrastructure that makes our modern, split-second digital lives possible. Welcome to This Explainer. I am so thrilled you're joining us. In this session, we're going to demystify the complex journey of data. We're going to track it from its chaotic, messy origins all the way to the pristine, actionable insights that power AI and massive business decisions. It's a journey from pure chaos to perfect order. Here's our roadmap for today. We'll be covering 1. The origin of data. 2. Methods of data acquisition. 3. Batch versus streaming. 4. Building ingestion architectures, and finally, 5, choosing the right pattern. Let's jump right in. All right, Section 1, the origin of data, where it all begins. Data literally lives everywhere, and every single birthplace presents a totally different headache for a data engineer. Imagine dealing with IoT devices, things like smartwatches, traffic sensors, or factory machines. They are just constantly blasting out data. The challenge there is the sheer volume and relentless velocity. It is quite literally like trying to drink from a fire hose. Then you've got APIs from external systems, maybe weather portals or financial market feeds. They have their own strict rules, often hitting you with rate limits and throttling, basically cutting you off if you ask for too much data too fast. And finally, internal systems, like a company's own ERP database. Now you'd think these would be the easy ones, right? Actually, scratch that. They can be the worst. The massive hurdle here is dealing with entrenched data silos across departments and incredibly inconsistent formatting standards. So every source throws a unique puzzle at us that we have to solve before we can even think about using the data. Moving on to Section 2, methods of data acquisition. Basically, how do we catch all this messy data? Once we actually know where the data is, we have to build the funnels to collect it. And we've got several tools in our tool belt for this. We can use database connectors to directly extract and pull data from operational databases. If we're pulling from the web, we'll use APIs, usually REST or GraphQL. Sometimes good old-fashioned file transfers are still the way to go. But when we're dealing with really high-velocity data, we rely on message queues, think Kafka, where data is published to a queue and then reliably consumed by our apps. The real trick here, though, is balance. You want the most reliable funnel possible, for sure. But if you overcomplicate it, the whole system becomes an absolute nightmare to maintain. Which brings us perfectly to Section 3, batch versus streaming. This is the classic speed versus simplicity showdown. We basically have two main options for moving our data. On one hand, we have batch ingestion. Think of this like moving water using buckets at scheduled times, say every night at midnight. You collect your data in groups or chunks. It's simple to implement, it's incredibly cost-effective, and it's fantastic for large volumes of historical reporting. But it comes with high latency, meaning that data isn't immediately available to you. On the other hand, we have streaming ingestion. This is a continuous real-time hose of data. It happens record by record, event by event. The massive advantage here? Real-time insights. It is absolutely perfect for instant alerts or personalization. But the catch is that it's far more complex to design, requires continuous operational monitoring, and yeah, it can be a lot more expensive. So the crucial concept underlying all of this is latency. Latency is simply the delay before your data is actually available for you to use. It's the travel time from the source to the destination. Honestly, for a data engineer, latency is the ultimate deciding factor. If your business can survive on yesterday's data, you choose batch. Easy. But if you need to know exactly what is happening right this very second, you just have to embrace the complexity of streaming. All right, Section 4, building ingestion architectures. The quest for the best of both worlds. Let's look at the ingenious architectures engineers have built to resolve that tension between speed and historical accuracy. Our first major design pattern is the Lambda architecture. Lambda basically asks, well, why not both? Here, raw incoming data is split into two simultaneous paths. It goes through a batch layer to ensure completely accurate historical data, and it simultaneously goes through a speed layer or a streaming layer for real-time calculations. A classic example is a bank. They use the batch layer to process your daily reports and monthly account summaries perfectly, but they simultaneously use the streaming layer to monitor the ATM you're currently standing at, so they can detect any suspicious, fraudulent transactions instantly. It really is the best of both worlds. But there is a huge trade-off. You are literally maintaining two completely separate processing pipelines. That means way higher complexity, duplicated logic, and much higher maintenance costs. Because Lambda was so heavy to maintain, some brilliant engineers pivoted to the Kappa architecture. Kappa dramatically simplifies things by saying, let's just treat everything as a stream. It uses a single stream processing pipeline for both real-time and historical use cases. Companies like Uber use this for real-time ride tracking, or Netflix for those instant video streaming recommendations. It is so much easier to maintain because you only have to build the system once. But, and this is a pretty big but, there's a key requirement. To fix mistakes or build historical views, your system must durably store all events and support event replay. Essentially, you have to be able to rewind the tape and process the stream from the very beginning at any time. Which brings us to the current heavyweight champion of the data world, the modern Lakehouse. What companies are increasingly using today is a unified platform that combines the incredibly cheap, vast storage of a data lake with the high performance and strict governance of a traditional data warehouse. Through open table storage formats, things like Delta Lake or Apache Iceberg, the Lakehouse provides a single, scalable foundation. It gracefully handles both batch and streaming workloads without those immense operational headaches of the past. It's a real game changer that essentially future-proofs the organization. Now let's see how this builds into what we call the medallion architecture inside a Lakehouse. This perfectly illustrates the mini-narrative of our drop of data. First, the data lands in the bronze layer. This is the raw, untouched, immutable data exactly as it arrived from those chaotic sources. Then it flows into the silver layer. Here, our drop of data goes through a filter. It gets cleaned, validated, deduplicated, and enriched. Finally, it arrives at the gold layer. This is the highly curated, beautifully organized business-level data that is perfectly prepped to power executive dashboards, business intelligence, and complex machine learning models. Final stretch, Section 5, choosing the right pattern, how to align all of this with what you actually need. Look, there is absolutely no one-size-fits-all pattern in data engineering. So think of this as your ultimate cheat sheet. If you just need to run employee payroll once a day, stick with batch. It's low complexity and hits the nail on the head for that task. If you're monitoring IoT sensors on a factory floor, you gotta go with streaming. Now, if you're a financial institution that requires rock-solid historical accuracy plus instant fraud alerts, you might just have to endure the high complexity of Lambda. Ride-sharing apps, they thrive on Kappa. And if you are building a modern, highly scalable data platform for a massive variety of analytics and machine learning workloads, the Lakehouse is almost certainly your target. The big takeaway here? Always align your architecture with your precise business requirements and data characteristics. To wrap up this explainer, I want to leave you with a quick thought exercise to cement everything we've just learned. Imagine you're the lead data engineer building a brand new smart banking application. Business leadership comes to you and says, hey, we need split-second fraud detection to protect our customers, but our regulators also require perfect end-of-day consolidated transaction reports. Given everything we've covered today, the trade-offs of latency, the complexity of maintaining multiple pipelines, the evolution of modern platforms, which ingestion pattern are you going to choose, and why? Ponder that next time you swipe your card or look at your phone. Thank you so much for joining me on this journey from chaos to order. Keep exploring, keep learning, and I will see you in the next explainer.